So guys, here as you can see that I have used these two single strand copper wires to hold the brushes back in their place because they were not allowing the commutator to get in this slot. Before I do that, I will also have to place it in this. Yeah, now it's gone, and now I can take it out, this one as well as this one. It's in contact with the brushes. Now it's time finally to place the rotor back in the field. Well, it's not very smooth. Seems like there is some problem with the bushes of the armature. So guys, from the previous video, your question for today is what was the maximum weight that I pulled with the photocopy machine motor? So guys, the motor was not working properly. You see this piece, this was connected here to the shaft at the back, and there was another piece but it was missing in the motor from the beginning, so I had to make this other workpiece, and this piece is like perfect for this, and all the dimensions are matching 100%. You see that plastic bore, in that I have to place this back of the shaft with that holder. So let's do that. Nice fit. Now let's tighten up the screws and see how it performs. Somehow the motor was lying around and not working, like thrown away, and it also had two missing screws, which means that it had been opened initially, and during the repairing, the repair person lost the piece. So guys, the motor is fully complete now, and you can see that I've placed two more screws. You see, little different, but yeah, they fit perfectly, and now it is running pretty good. Let's test it with a 12 volts battery. And guys, now I have another beautiful motor in my collection. Pretty good performance. It's running really nice.
So guys, your hidden question from the previous video is, which transistor did I use to reduce the base current of the giant transistor?
So guys, after installing the gearbox and placing it on the vise, I have replaced the batteries. These batteries are 12 volts each, 7 amps, and this is the BLDC motor speed controller. Link will be provided in the description. You can increase the speed and decrease it with this knob, and this is the anti-clockwise and clockwise moving switch, and the red wire indicates the positive, which is still not connected to this one. So let's connect it, and you can see that it has started running. Torque is very high, almost unstoppable. 200 kg centimeter. Now let's increase the speed further. It is 24 volts. More, full speed. That's the full speed. Yeah, I cannot stop it. 200 kg centimeter, pretty good torque. Now let's move it to anti-clockwise. Starting it. So guys, there as you can see that I've coupled a heavy water pump with that motor, and I'm going to turn it on and see how powerful the motor is, if it can pull it towards itself. And at the same time I will also have to hold the motor itself, because there could be a counteraction. The weight is too heavy, this might get pulled towards that, and this entire setup might go under a short circuit. So let's start. Well guys, this time I've connected a 20 kg load with this rope to the motor. Okay, and I have tied up the motor with another rope so that I don't have to hold it. Okay. Pretty good, right? So guys, today in this video I'm going to convert it into a short, compact and portable battery operated DC pump. Now guys, the first thing that you will notice is the exceptionally large shaft. So to make it compact, I will have to cut it a little bit. Now guys, this what you see is a heavy duty ABS plastic case in which I am planning on installing the 12 volts UPS battery, the 12 volts DC motor and the pump itself. Now guys, this is an unwanted plastic projection that is getting in the way of pump insertion. So guys, I'm going to cut it off with the help of my drill press. I'm going to bore an even bigger hole than this one so that the extra part cuts off automatically.
So guys, here as you can see that I have placed the pump like this with the strip, and it is rigid and strong, and the shaft is also moving pretty good. Now comes the part of connecting the DC motor to the shaft, and I have already cared about the alignment. You can see there are some cushioning provided to bring the shaft to the height of the motor slot. Okay, you see it's almost identical.
But before connecting the motor to the pump itself, I will have to take care for the motor itself, because there is a possibility that the water leaks from the pump with time, and it like rusts the clutch system or anything. So I have to take care about that problem if it arrives in the future. So starting with this is this thick foam, okay, and size is going to be this much. And I will have to place it like this. After doing all that comes the part of placing this PVC sheet on this battery, because you see these slots. When the battery charges, bubbles come out from the water or the dilute sulfuric acid inside, which pushes the cap upwards, and there is some leakage of the acid. So to prevent that, I will be placing this PVC sheet. It will allow air to escape but also prevent the caps from flying out like a rocket. Now guys, after completing the process of taping of the battery for protection from the acid leaking, comes the part of keeping the motor in place with the help of aluminum strip sheet. So let's give it a spin and see how it is working. Okay. See, pretty good. So guys, here as you can see that I have taken one wire from the DC motor, the black one, and I have connected it to the switch over here. Okay, and the second wire is not connected anywhere except to this clip, which will be connected directly to the 12 volt 7Ah battery. Okay. Now there is one more terminal left on the switch, and to this terminal I will connect this yellow wire, which will again be connected from this side to the 7Ah battery. So guys, after doing all this wiring, it's finally time to connect the battery. Okay, so this is the battery. So yes, the battery has also been placed. Now guys, this yellow wire, I will connect it to the negative terminal first. Okay, that's the negative terminal. Now comes the positive wire, the only left out wire. Yeah, so let's connect this one too. Okay, yeah, so this one is also connected. Now let's turn on the switch. You see, it's working. This, what you see guys, is a USB port which I'm going to use to charge this 12 volts battery, although this port is used usually for 5 volts, as you have seen in mobile charging systems and chargers.
Here as you can see, I have also placed hot glue so that it fixes strongly and rigidly, and this is the USB cable, and it is going to be something like this. And this red LED is going to indicate the starting of charging of the battery when I connect the USB cable over here.
Now guys, this is 1 kilo ohm resistor which I'm going to connect with this LED in series to limit the current flow.
This black wire from the USB port is going to be connected to this resistor. Okay.
You see it is glowing.
So to prevent that, I'm going to use this 6 amperes diode. Okay, and this is the positive side of the diode, which will be connected to the LED over here, and the negative to this white terminal.
Okay, you see now the light bulb is not glowing, and that's done. So diode has been connected, charging cable has been connected, everything done. Now comes the testing part and also the back cover.
So guys, here as you can see that the charging system at the pump, the motor as well as the battery all have been placed, and this is the main switch. Okay, and this red LED you see, it was going to indicate when the charger is connected to this setup.
Let's turn it on and see how it works. See, it's working. Well guys, this plastic piece, you see, this is going to be the cover of the water pump, and here as you can see I have made a mark where I'm going to drill a hole, and this part was little cracked, so I've used Fabricating to fix it again. So it's finally time to cover the head.
Here as you can see guys, I've placed 7 screws, this, then 2 on this side, and then again 2 on this side. Together 7 screws holding the 2 cases strongly. This is the cover, and a lower piece is the one holding the battery, motor and the pump along with all the remaining circuitry. And guys, now comes the part of placing the handle. You can see that I have given a curve over here that is going to be placed like this. Let's drill a hole over here for placing a bolt.
So guys, this one that you see is the hole that I bored, and this piece I have made the marking at the back, and I have to cut off this piece from here so that it can be placed here like this. Now guys, this what you see is a 15 volts 3 amperes laptop charger, as I have already showed you in many of my previous videos. I have cut off its main cable and connected this USB cable that I showed you at the beginning of this water pump video. Now when I'm going to connect this over here, you have seen the red LED. So this is going to indicate if it has started charging or not. And as you can see that the LED has started glowing, indicating that the charging part has started. So leave it for a few hours, and also the charging is under protection. I'm using a 15 volts charger, but I've connected a diode in series. So the diode is going to cut off the 15 volts to around 14.3 volts, which is ideally needed for charging the 12 volts UPS battery.
Here as you can see, this is the pressure I'm getting from the tap water. You see, slow pressure. So this is the extension pipe that goes to the booster pump, and here this actual pipe connects to this. That's the normal pressure. Let's boost it, okay, with this switch. It's filling up really fast. Okay, so this is the normal pressure that we get. Now let's boost it. Oh,